So this is a little experiment with mass-produced off-the-shelf window air conditioner. Got this one off of Craigslist for about 50 bucks and started taking it apart. So I took off, here we have the sides are off, the little foam insulation has been removed, and then here we have it off. You can see the plate on the bottom, it's been disconnected from that. The electronics have been disconnected from from the structure, but still wired together. Here the fan has been pulled out, so you can see the individual parts. Now we will be keeping that base. You can see the 3 points where the compressor mounts down to. That'll be convenient later on, so we'll be keeping that. Here all those pieces are pulled apart, and on the bottom in the middle you can see the part where the compressor bolts down to has been pulled out and cut out from the rest of the plate, and the coolant lines have been very carefully bent into position. And then on the power of the unit, this is a 5,000 roughly BTU window air conditioner. It's rated at 455 watts of power from a 110 line. Nothing really fancy about that. It's just mass-produced heat pump. The 35 watt fan I took off is probably going to get replaced with 35 watts or so worth of pump and so forth, so that won't be an energy saver on its own. The compressor it comes with is thermally protected.
Okay, so this is the quick, crude first test of concept for the converted window air conditioning system. I took the fans off and bent out the heat exchangers, cold side and hot side, sunk them into two separate 55-gallon drums of water to see how well that does being bastardized for that. It's rated to say a max of 450 watts. Right now we're just under 300, 296, and it just started. So we'll see what happens after it's been running for a little while. So after almost 6 hours of testing, the compressor is up to 545 watts power. The compressor is 184 degrees. The hot tank on top, 128. Top on the side, 122. Bottom, 66. Cold tank on top, 51. On the side, 48, 50. In the bottom, we got 45. Floor is still 61. And objects in the room are still about 70.
So here I downsized those drums into two buckets that are roughly the size of the heat exchangers, the hot and cold side. That way you're not oversized, and the water baths for each side are better fit to those hot radiator and cold radiator.
So I carefully bent the copper tubing so it doesn't get pinched. So the cold side, which is over the side inside the house, both inlet outlet tubes are now coming out the top, and the hot side as well, carefully bent so that the tubes inlet outlet are coming out the top, and the compressor sits in the middle. This is just a bucket that's just slipped over the top of that, and a bucket and we'll pack together bucket, but it's just over the top of that. That way the heat exchangers can be submerged, and it's going to start here. It's going to pump out this low temperature, next to the 80-degree vinyl tubing, where I wrapped the compressor in 1/4-inch copper pipe that will slightly cool the compressor and kind of preheat the water a little bit before it comes back up into, when it goes into the hot bucket, I did transition to 180 degree this red PEX, so that will take those temperatures. We're not going to get 180 degrees, but it'll do better for that.
So then it occurred to me that it would be better, instead of just sitting in a bath, if the water had to flow through the radiator, either hot or cold side. So I used some silicone sealant, which is good cold enough and hot enough once cured, and some foil tape, which is water impermeable and can take the temperatures as well, in order to seal up the two sides of the radiator. Here you can see the hot side radiator sealed up, top on the bottom and right left side, and here we have the cold side radiator also sealed up, bottom and right left. That will mean now that the water has to flow through the radiator in order to get to the other side.
So the evolution of this, as you see in the previous part of the videos, we have the drums, which were big and worked, but we had water stratification, and then we had smaller containers for the hot and cold, which worked better. And then we added blockers on the side, so the water would have to flow from one side to the other for both hot and cold. But that second step, or I guess that's the third step of putting the blockers, is it didn't specify where in this evaporator and condenser the water flowed through, so that wasn't the most efficient way or maximizing for extraction. So my thought was to have like a serpentine. So we have the lines that come in and go out and so forth on the two sides for hot and cold. So if I have a serpentine that kind of goes, that has the working fluid go back and forth, kind of like just snaking through here, not the refrigerant. The refrigerant stays sealed inside that system, but separate from that, my working fluid, the one that I'm either, when I want heat, the heat pumps to me and the cold is the opposite, and when I want the cold comes to me and the heat is the opposite. So, so the working fluid will be snaking back forth. And here, let me show you what I did for that. So here I'm working on the prototype for that snaking, and so what I did is I just took some basic copper pipe, and this doesn't have to be copper, but it will have to be something that can withstand the coldest side that you will see on the cold side, including if your working fluid has antifreeze or something in it, it gets below freezing, or on the hot side, if you're going to be storing temperatures. Now, you're probably not going to go above 200 degrees Fahrenheit, for storing in water or water even with an additive, but you could be reasonably in that range. Anyway. The idea here is that, it snakes in and goes back and snakes in and goes back. So this is going to be one side, and that's going to be the other of the hot side radiator and the cold side radiator in these little pieces, and I'm going to join them all together, either with a high temperature waterproof adhesive, or I'll just solder them together, either way. So this will be one side, that'll be the other side, one side for the cold, and then I'll take those and I'll attach them to the condenser and evaporator on the refrigerant, hot and cold sides. So we'll see how that turns out a little bit.
One of the ironies that occurs to me, this fifth step, the fourth version or evolution of this for me, is that this snaking, going back and forth through the radiators, hot or cold side radiators, if that's done in a water sealed way, then the original configuration of the way the window air conditioner comes in a box could have very likely been preserved. And they could have just left it mounted there, left everything mounted to the plate, and just have that snaking back and forth of the radiator. The fan comes out, and a pump with inlet-outlet lines replaces it. So that's a bit of an irony for me. That might show up here at the end. I might redo the whole project from the beginning like that as a more refined, but that's just a bit of an irony.